All right, so problem E on our example here. 3x to the fourth minus x to the third plus 8x squared plus 5x plus 3 divided by x squared minus x plus 3. This problem is different because, unlike our other long division problems, we have 3 terms in our denominator. It's not just x plus 5 or x minus 4. We have 3 separate terms, and we have to figure out how to deal with that. Now, we can still set up the problem the exact same way we would otherwise. Long division with our divisor on the outside, and what we call the dividend on the inside. 3x to the fourth minus x cubed plus 8x squared plus 5x plus 3. Now, even though there are 3 terms, seems like it's going to be completely different, but in reality, we still do this exact same thing where we try to make our first term match our first term here. Our first term on the outside match the first term on the inside. So we ask ourselves, how do we make x squared match 3x to the fourth? We multiply it by 3x squared, right? Because 3x squared times x squared makes 3x to the fourth. So we try to make it mirror that number. So once we determine what would make it match, we actually distribute this into all 3 of these terms. So we distribute it into x squared, we get 3x to the fourth, and we start writing it underneath this division bar. 3x squared times negative x is going to be a negative 3, and then it turns into x to the third. Finally, we have 3 times 3x squared, and we get, what, 9x squared? Once we have this distributed in, we've created our entire subtraction problem here. We go ahead and subtract these. 3x to the fourth minus 3x to the fourth, that's 0. It cancels out. Then, we always do have to remember, as we move along here, we are still subtracting regardless of what this sign is. So negative x to the third minus negative 3x to the third. These 2 negatives are going to counteract each other, turn into a positive. So we'll have negative x to the third plus 3x to the third, making 2x to the third. Finally, we have 8x squared minus 9x squared, making negative x squared. Our remaining ones that were not part of this are going to drop down, and they'll be in our next step. Now we ask ourselves again, how do we make this first term, this x squared, match our first term underneath the division bar? So how do we make x squared match 2x to the third? We multiply by 2x. That's all there is. So I'm going to put a positive 2x up here, just like I put my 3x squared up there. That 2x is going to distribute into this in the same way the 3x squared did. Now 2x times x squared is going to be 2x to the third, exactly what we want it to be. 2x times negative x is going to become negative 2x squared. And then 2x times 3 will make a positive 6x. Again, we subtract, we subtract these. Thank you, Keegan. 2x cubed minus 2x cubed gets us 0. Negative x squared minus 2x squared. So remember, these negatives are going to counteract. It's negative x squared plus 2x squared is going to be a positive 1x squared. These will subtract. 5 minus 6 will become negative, not 6, but just negative 1x. And then 3 will drop down as per usual. We're in our final step. We ask ourselves, what do we multiply x squared by to turn it into x squared? 1. It already is that, right? We don't have to multiply it by anything. So we multiply it by 1. This 1 distributes in just like all the others did. And anytime you multiply something by 1, it just turns into the same thing. So we get x squared minus x plus 3. And since we are subtracting literally the same thing from what we have, it turns into a 0. Making 3x squared plus 2x plus 1 our final answer. The remainder, not the remainder, but what is left after we divide out x squared minus x plus 3. All right.